Horizontal asymptotes are the long-term behavior of a function, or what happens as we go to positive or negative infinity. Let's look at y equals 5 over x minus 6, and let's just go out to infinity. We can do that in math. Let's put 5 over a big number minus 6. Well, a big number minus 6 is really, really big. And then 5 divided by a huge big number is going to be really small. If we put in a negative big number, we're going to have a negative big number minus 6, which will be a negative big number. And then 5 divided by a really big negative number is really, really tiny. So it's going to go to 0 both ways, positive and negative infinity. So our horizontal asymptote in this case is y equals 0, which happens to be the x-axis. Let's look at this example. Let's say we put in a big number. We're going to have a big number squared times 5, which is still big, plus 2. We're going to have a really big number in our numerator. In our denominator, we're going to have 5 minus a big number minus an even bigger number, so we'll have a really big negative number. So what happens if you divide a big number divided by a negative big number? Well, it's undetermined actually. We're going to have to use some algebra and not just guess on this one. We're going to take the highest power of x that occurs in the denominator and pull it out of the numerator and denominator. Now we can cancel our x squareds. And now let's see what happens as we put in a really big number for x. 5 is still 5. 2 divided by a really big number squared, this is going to go to 0. Same thing here, this will go to 0. We have 3 divided by a really big number, that goes to 0. So this will go to 5 over negative 1. Y goes to negative 5 as x goes to positive infinity. Now all these things will still go to 0 if it's a negative infinity. So this is a plus or minus. So our horizontal asymptote is y equals negative 5. Now you might be able to guess a shortcut here. This 5 came from the coefficient of our highest power in the numerator, and this negative 1 came from the coefficient of the highest power in our denominator. A shortcut is to analyze the behavior of the ratio of the leading terms. What happens to 5x squared over negative x squared as x goes to positive or negative infinity? Well, these cancel and it goes to negative 5. Let's find the horizontal asymptote. The first way I taught you was to pull out x to the power of the leading term in our denominator. So let's do that. We can cancel these and see what happens as x gets really, really big. Well, this goes to 0, this goes to 0, these go to 0. 1 divided by a really, really big number goes to 0. So we're left with 0 over 1, which is 0. So our horizontal asymptote is y equals 0. Let's do the shortcut. Leading terms are the terms with the highest power of x in them. So we're going to have an x over x squared, and this goes to 0 as x goes to positive or negative infinity. So our horizontal asymptote again is y equals 0. Let's find the horizontal asymptote of the reciprocal of the function we just did. Pull out the highest power in our denominator, and let's see what happens as x gets really big. 1 over x goes to 0, 2 stays just 2, but x is going to get really, really, really big. But it's going to go to negative infinity as x goes to negative infinity. We'll have a really, really big negative number plus 2. It's going to be a big negative number. So this one has no horizontal asymptotes. Well, let's think about how we find horizontal asymptotes. It's in behavior. It has nothing to do with intermediate behavior. So yes, it can. If we distribute things through, we're going to get 5x minus 5 over x squared plus x. So our horizontal asymptote is y equals 0, which is our x-axis. We have an x-intercept at x equals 1. So our ordered pair is 1, 0, which lies on the x-axis. So it did cross it.